Hey there, we are looking at 4.9 today, comparing linear functions as we close out Unit 4. Our objective here is to be able to compare linear functions that are represented in different ways. And those could include graphing tables, function rules, all of those included. And so it encompasses basically many of the standards that we've been doing this entire chapter. And so let's talk about what it means to compare linear functions. And then we'll get into the specifics of certain methods. So when we compare linear functions, we're talking about their main characteristics. So mainly we're talking about comparing the slopes of one another or the y-intercepts of one another. Sometimes we'll talk about the x-intercepts as well. But remember that a linear function is in the form y equals mx plus b. So when we look at that, we're looking for two things, the slope and the y-intercept, to be able to compare them together. And so we're going to first look at a table and a function rule. And so a table and a function rule are two ways that linear relationships could be expressed. It may be helpful to convert one representation to the other when comparing the two relationships. Sometimes the comparisons can be completed without converting either representation. It might be easy enough to see the pattern of what's going on. So let's look at example 1 and talk about what's happening with this example. So f of x and g of x are linear functions. Both the domain of both functions is a set of all real numbers such that x is in this set of values from 2 to 6. And that's what we have written here. 2 less than or equal to x, less than or equal to 6. So it means my domain is only between the values of 2 and 6. The table shows some ordered pairs belonging to f of x, and the function g of x is defined by this rule here. G of x is equal to 3x minus 1. And so what it's asking us to find is the initial value and the range of each function, because we're already told the domain. We're told that the domain of both functions was 2 less than or equal to x, less than or equal to 6. But let's talk about what is the initial value. Now, that's a term that we haven't really used. The initial value is going to be this. When we talk about like a line, right? So if I've got a line on the coordinate plane and it stops at 2 points, the initial value is going to be the y-coordinate of the point furthest to the left. It does not matter which way my line goes. If my line were drawn going across this way, right, my initial value would be at this point, because it is again the furthest point to the left. It does not matter which way this line slopes. It matters where it starts and where it ends. And remember that we describe functions as we go across the coordinate plane from left to right. That's how we think of our number line, going from negatives to positives. All right, so what is the initial value of each of these functions? So we're going to talk about these with the f of x function and the g of x function, and so kind of just making a little table here to organize all of our information that we're trying to find. So I'm going to start with the initial value, and I'm going to tell you that the table is going to be the easier one to do here, because we have the first value here. When x is 2, that's the left part of our domain. What's the y value? It's 8. So the initial value here is 8. And f of x is also really easy to do for this table, because the range of it will start at 8 and goes to what? 20. So I'm going to write 8 is less than or equal to y, because remember we're talking about the range, less than or equal to 20. So that's it for that problem when it comes to the f of x function. Now we need to do it for the g of x function. This is where we're going to have to do a little bit of work to find that. And that comes back to knowing our domain. So g of 2 is equal to 3 times 2 minus 1. So that gives us 6 minus 1. So g of 2 is equal to 5. So my initial value is 5. Now I need the other end of our domain to get the last range value. And so I'm going to plug in the 6 now. So g of 6 is equal to 3 times 6 minus 1. So that's 18 minus 1, meaning that g of 6 is equal to 17. And so this goes from 5 less than or equal to y less than or equal to 17. And so that is just finding the initial values and the ranges of these functions. We haven't done anything even to really compare what's happening. But we could talk about it, right? We could say, which of the two functions has a greater initial value? Is it the f of x or the g of x? Well, the one that has the greater initial value would be the one that has the higher value. So that's the 8, right? We could talk about the span of the ranges. You know, how far is it from the smallest range value to the largest range value? And in this case, they're both the same size. This goes from 8 to 20. This goes from 5 to 17. They're the same distance apart because 17 minus 5 is 12, and 20 minus 8 is also 12. All right, so let's look at another example here. In this problem, we're going to compare the description, in this case in a table, to a graph. And so the linear function f of x is defined in the table below, and the linear function g of x is defined by the graph below. Assume that the domain of f of x includes all the real numbers between the least and greatest values shown in the table. And then for g of x, we see the graph, and so we can talk about the domain of it. So let's talk about the information that we're going to take out and compare for f of x and for g of x in this problem. We're going to talk about the domains of both. We're going to talk about the initial values of both. And we're going to talk about the range of both. And those questions are listed below. If we scroll down here, we'll see that all those questions are listed here. But again, we're just going to organize our information on the screen here while we can see everything. Okay, so what is the domain? Well, pay attention to this statement that they gave us here. Assume that the domain of f of x includes all the real numbers between the least and greatest values in the table. So domain is x, so I'm going from the least to the greatest, which means my domain will be from 0 to 5. So 0 less than or equal to x less than or equal to 5. Now, what's my initial value? Again, remember that is at the leftmost part of my domain. What's the value of the f of x? It's -3. What's the range of this? And that's going to go from the smallest value to the largest value, right? And sometimes those values will go in opposite directions, so pay attention to that. So it goes from -3 to 17. So -3 less than or equal to y less than or equal to 17. So again, it's not hard to build this information if you understand where you're looking to get it. All right. Now let's talk about the graph. The graph domain, remember, is our x. So where do we start and where do we end in x? Well, it's 0 less than or equal to x less than or equal to 5. So what we see is that these two functions have the same domain defined for them. They're both from 0 to 5. Now, what's the initial value? Well, again, that's going to be this point here, and that order pair is at 0, 2. So my y value, the initial value, is 2. And the range, it's going to start at 2 because that's our lowest y value, less than or equal to y, less than or equal to what? I need the highest y value. And that highest y value is here, and if I track it all the way back across, we're going to see that we're at 22, because this order pair here is 5, 22. That's it, y'all. Again, it's not any more complicated than that. It's really not. So don't make this harder than it looks, because you know, you're looking at graphs, you're looking at functions, you're looking at word problems, and you're like, oh my god, what am I looking at? Don't. Just relax for a minute and understand, you know what domain is. Domain is the inputs, range is the outputs, domain is your x, range is your y. The only thing that's really new is this initial value, and that's again the y value of the leftmost point. Okay? So again, we could fill everything out here to write it out. So 0 less than or equal to x less than or equal to 5, 0 less than or equal to x less than or equal to 5, and this is just all the information coming from the table that we just did. The initial value here was -3, and for g of x it was 2. And the ranges -3 less than or equal to y less than or equal to 17, and then 2 less than or equal to y less than or equal to 22. So there we go. All right, we got one last example that we're going to look at. So with example 3, we're going to look at this word problem here. Sylvia works 7 to 20 hours per week, and she earns $8.50 an hour. Her friend Grace works for another company. Her pay for t hours each week is given by the function g of t is equal to 9t, where 6 is less than or equal to t, less than or equal to 15. So it's asking us to first find the domain range of each function and then compare their hourly wages and the amount they earn each week. So let's talk about these two different people that are working, right? So Sylvia works between 7 and 20 hours. That's our domain. Because again, the hours that we're working is our input and the pay is the output, right? So I'm going to define this function as S of t. Now, if I'm getting paid to work so many hours, it's going to be the amount that I'm paid per hour times the number of hours that I work. And so I'm going to get 850 times the t. And then we're already told for Grace that Grace is going to be 9t. So what does that mean in this problem? What's the 9 mean? Well, think about this. What was the 850 here? The 850 was how much Sylvia made per hour, right? So the 9 is what? It's the amount that Grace makes per hour. So let's make a little table here and talk about our two functions. We're going to have S of t and we're going to have g of t, standing for Sylvia and Grace. And so we're going to talk about the domains and we're going to talk about the ranges. So the domain of these is based on the hours that they're able to work, right? Because that's what the x is, or the t is in this problem. And so the domain for Sylvia was given here. It's 7 less than or equal to t less than or equal to 20. And for Grace, it was already given to us here. Grace can work between 6 hours and 15 hours. Now, how do we get the ranges? We got to go back to what we did in problem number 1. We've got to plug in values to find what's the low end and the high end of our range. And so we're going to have to do a little bit of work here to do this. So for Sylvia, we're going to do S of 7, because that's the beginning of her domain, and 850 times the 7. And that gives us $59.50. And Sylvia's high end is when she works 20 hours. And so we're going to get 850 times the 20. And so 850 times 20 is $170. And so the range for Sylvia is this. It is from $59.50 less than or equal to S of t less than or equal to 170. Okay, because we didn't define a dependent variable in just one single letter, we defined it in function terms here. All right, we'll do the same for Grace. And so g of t, or g, not g of t, but g of 6, because that's where she starts, 6 hours. So that's going to be the 9 times the 6, and that's 54. So g of 6 is 54. Less than or equal to g of t, less than or equal to g of 15. So 9 times 15, and so g of 15 is 135. So she can make up to 135. So let's compare their hourly wages and the amount they'll earn each week. And so Sylvia can make between $59.50 and $170. Grace can earn between $54 and $135. And so these values would differ depending on the number of hours that they could work. Some weeks Sylvia will make more money than Grace because maybe Sylvia works more hours than Grace does, and she would make more in that sense because she, even though she earns less per hour, if she works more hours, she's going to make more, right? And we see that here, right? Sylvia's low end is $59.50 because she worked 7 hours minimum, whereas Grace earns more money, but her minimum number of hours is only 6 hours a week, so she would earn less. So that's it for section 3. Or sorry, not section 3. We're on section 9. And example 3, right? So that's it. The word of the day is to compare. And so again, the word of the day is compare. And so make sure you submit that into the Google form. And again, if you have any questions, make sure you log on to the Zoom chat from 11:30 to 12:30. Or if you need to email me, and we can work through whatever you have. Again, I hope you all have a great day. Stay safe.